remember the equation of standard form. There are three things we don't know. We don't know A, we don't know B, we don't know C. So, this requires me to have at least three coordinates from some quadratic function to find A, B, and C. And one of the ways you could do that is with elimination, which that's, kind of time consuming. And the other way we did it with technology was with matrices. So we're going to pick matrices. Okay, so in order to do this, remember, we're going to set up our equations. We're going to start with -3, 36, 0, 3, and 4, 15. Okay, and we're going to make three equations out of these. Now remember, you're substituting for the x's and the y's. So this is going to be something equals something times A plus something times B plus C. Something equals something times A plus something times B plus C. Something equals something times A plus something times B plus C. And so the big question is, what goes in those spots? Well, if the y value is 36, you know what we should do? We should flip this around and put the y on the other side of the equation. That way, when we write this out, okay, we can put the equals 36 over here instead of over there, okay? Okay, all right, this will be more helpful. We'll put our equals on the other side. Okay, so back to my original coordinate. Okay, so if I plug in a -3, remember, you're squaring the first one, so that would be 9, right? Because remember, the x gets squared on the first part. The x does not get squared on the second part, so that's just going to be -3. When I go to the next one, 0 squared still 0, 0 is still 0, equals 3. Last one, 4 gets squared, and that's going to be 16. 4 does not get squared, and then 15. Well, now that we have our equation, we can set up our matrix system. 9, -3, 1, 36. Remember how we would separate that last row off, because that's where my constants are at. 0, 0, 1, 3, 16, 4, 1, and 15. And now, come over to our handy-dandy matrix A. Oops, probably need to make a new matrix. And we want 3 rows and 4 columns. And now we can start, plugging in our information. And then remember how we do this? We would go down to the next one and do RREF matrix A. Voila! There's our answer to this question. Now, who the heck made this? They didn't leave enough room. So, obviously my matrix 1, 0, 0, 2, 0, 1, 0, -5, and 0, 0, 1, 3. Now, you need to know that tells me I have y equals 2x squared minus 5x plus 3. We found the A, we found the B, we found the C. We let the calculator do the work. So, the most work we're going to have to do is finding the equations, and then we can use the calculator to do the rest of the work. So let's see here. Negative 2, 21, 2, 3, 6, negative 5. So something times A plus something times B plus C equals 21. Something times A plus something times B plus C equals 3. Something times A plus something times B plus C equals negative 5. And we can see, alright, so let's see here. Remember, the first one is the squared one, the second one is not the squared one. So negative 2 times negative 2 is positive 4, but that one's got to be a negative 2. This one has to be a positive 4, and this one has to be a positive 2. And lastly, 6 squared is 36, and 6. So now we can go to our matrices, right? 4, negative 2, 1, 21. 4, positive 2, 1, 3. 36, 6, 1, negative 5. Does anybody recognize something going on in this column right here? That's kind of interesting. So now we're going to do the RREF for that and get our new matrix, and then we will know what to put in front in those 3 spots. So might as well come back up here and start typing. 4 tab negative 2 tab 1 tab 21 tab 4 2 oops not 5 2 1 and 3 shift tab 36 tab 6. Make sure my numbers are at 4 negative 2 1 21 4 2 1 3 36 6 1 negative 5. Whoa, is that really true? Do we really have ugly numbers like that? Let me look again. 4 negative 2 1 21 4 2 1 3 36 6 1 negative 5. Oh, I caught a mistake. Yes. Couldn't copy down the negative. Ooh, glad we caught that. That threw everything off, didn't it? Because now, it looks so beautiful. Okay. So, 1 0 0 negative 1 0 1 0 6 0 0 1 negative 5, and so now we know negative 1 goes there, 6 goes there, and if you want to, you can just get rid of that and make it a negative 5. And there's your answer for the second one. All right, let's do another one here. Very, very important that we do not copy these down incorrectly the way that I did the last one. Something times A plus something times B plus C equals negative 15. Something times A plus something times B plus C equals negative 7. Something times A plus something times B plus C equals 35. Okay. So, remember the first one is the squared, the second one is not. So that's a 16 and a negative 4. And that is a 64 and a negative 8. And that is a 36 and a positive 6. And so now we can make our 16, negative 4, 1, negative 15. And our 64, negative 8, 1, and negative 7. And our 36, 6, 1, and 35. Oops, can't write. Said it, but can't write. And then do our RREF, which is going to spit out for us. Let's go back to the beginning. 16, negative 4, 1, negative 15, 64, negative 8, negative 7, 36, 6, 1, and 35. Oh, look at those nice numbers. Right? And so now we know 1, 0, 0, 0.5. You can use fractions if you want. There's nothing wrong with that. I don't care. 4, 0, 0, 1, and negative 7. And so now we have our equation. Oops. 0.5x squared plus 4x minus 7. That's that complete situation. See what we have on the next slide. Okay, so we're dealing with something called quadratic regression. Quadratic regression. Not to be confused with linear regression. So real data points that fall on or very close to a quadratic model. In other words, we're using data to find an equation. Use data to find an equation of the curve. Not always perfect, but it gives us a good idea. Eric is training for the discus throw. His coach recorded the horizontal distances and height of one of Eric's discus throws. All right, so we're going to come over here and we're going to make a table. And obviously you could see 1, 2, 3, and as soon as you do this on Desmos, it starts to auto-populate the x's 4, 5, 6, 7, 8, 9, and 10. Oop. 1.75, 2.71, 3.52, 4.28, 5.45, 6.12, 6.79, 7.34, 7.99, and 8.55. So you can see on my Desmos that it is graphing these things, and I do get what looks like a curve. Some people might say, oh, that looks like a straight line to me. But if you stretch it out a little bit, you see, no, it kind of has a curve shape to it. Oh, when we come up here and hit this little button, it's going to do some pretty cool stuff. Look at it. It put a line on the graph. Wait a second, I didn't want to do linear regression. I wanted to do quadratic regression. I wonder if I can just click this drop-down menu and choose. Oh, look, there it is, quadratic regression. Now, can we see? First, it created a line. Can you see that some of these points down here, not quite perfectly on the line? Definitely here in the middle, they're not quite on the line. Over here, we're not quite on the line. But here, when we do the quadratic regression, the points look a lot closer to the curve. A lot closer. Write a quadratic model, says round to the nearest thousandth. To the nearest thousandth. Okay? So, y equals negative 0.027 x cubed. Oops, not x cubed. What am I thinking? X squared. Quadratics aren't cubic functions. Plus 1.058 x plus 0.672. That's my equation. You can see it's right here. All I did was round it off to the thousandths place. They may ask me to do more things with it, but at least I know where I found it. What will be the height of the discus when it has traveled 15 meters from Eric? Okay, so I just have to plug in 15. Negative 0.027 times 15 squared plus 1.058 times 15 plus 0.672. Use my handy dandy calculator. Well, I guess maybe I could just type that on here. Negative 0.027 I use parentheses. Squared, let's see, plus 1.058 oops. Point 672. 10.467. All right, see what else we got going on here. So I think this one's maybe easier than the last one. We're going to see. Okay, let's get our data entered in. 0.2. Oops. Is that right? Nope, missed the decimal. That's why. Okay, so 0 gives me 10, 11.76, 12.24, 11.44, 0.8 goes with 9.36, and 6 itself. So here's my group of points. I think I'm going to shut the other one off. I can see all my coordinates are bunched up, so I'm going to stretch them out a little bit and see if I can see a parabolic pattern, which it looks like I am seeing a parabolic pattern. Now once again, I can hit the regression button right there and switch over to, let's see, what kind did they ask me for? A table shows the height of the football in feet above the ground at various times in seconds. Write a quadratic model for the data. Okay. It's pretty easy to write them. Y equals let's see here. Which coordinates do I want? So it looks like I have the equation y equals negative 16x squared plus 12x plus 10. That's the equation that goes with the picture. If the football was not touched by anyone on its way to the ground, about how long does it take the football to reach the ground after it was thrown? Well, looks like 1.25 seconds. You can see in my picture on the far right, it connects with the ground at 1.25 seconds. I think that's it for this particular question. So I think this lesson's over, but we'll see.